Logistic regression is a foundational algorithm in machine learning used for binary classification problems, where the outcome is either yes or no, true or false, 0 or 1. Despite the name, logistic regression is not actually used for regression. It's used to predict probabilities and classify inputs into one of two categories. Let's look at an example. Suppose you want to predict whether a student will pass or fail based on their study hours. You want the output to be either pass or fail. That's a classic use case for logistic regression. Unlike linear regression, logistic regression predicts a probability that an input belongs to a specific category. That probability is then used to assign a class label. To do this, logistic regression uses a special curve to map inputs to a range between 0 and 1. If the predicted value is closer to 1, the model classifies the input as belonging to the positive class. If it's closer to 0, it classifies it as the negative class. The model then draws a decision boundary to separate different classes. That boundary can be straight or curved, depending on the data and transformations applied. Training the model involves adjusting its internal settings so it performs better on new, unseen data. It does this by comparing its predictions to actual results and improving over time. To evaluate how well logistic regression performs, we use metrics like accuracy, precision, recall, and F1 score. These help us understand whether the model is making reliable predictions, especially when one category is much more common than the other. Logistic regression is widely used in the real world. Some common examples include email spam detection, predicting customer churn, diagnosing diseases, loan approval systems, and ad click prediction. Why do people like using logistic regression? It's easy to understand and quick to implement. It works well when the classes are linearly separable. It's efficient and interpretable. However, it also has limitations. It may not perform well with complex or nonlinear data. It's sensitive to irrelevant features and outliers. It requires clean and properly scaled data to work optimally. Even so, logistic regression is still one of the most commonly used algorithms in the machine learning toolbox. It's a great starting point for binary classification problems and is often used as a baseline model. If this video helped you understand logistic regression better, make sure to like, share, and comment below. Let us know what topic you want us to cover next.